Bismillahirrahmanirrahim. So the first topic that I wanted to discuss with you is regarding quantities. Okay. Now, which things can we say quantities? Anything that we can measure, we can say this is a quantity. Now, for example, if I tell you what is the length of this marker, if I ask you to measure the length, you can measure it, right? So as this is a
Yes.
measurable quantity, so length is a quantity. Now, if I tell you that, Saiful, are you happy? You will say that, yes, sir, I'm happy. If I ask you how much happy you are, will you be able to measure your happiness? Like, will you be able to tell me, sir, I am 5 kg happy. Will you be able to tell me like this? Will you be able to give me any quantity like that?
No, sir.
Okay, so as we were talking about that feelings, these things are not any measurable quantity, right? So as a result, we cannot say this is quantity. Anything that is measurable, that is only we can say and mention as quantity. Now, out of all the quantities, some are fundamental quantities. Okay, if you see, there is a table in page number 15, that is table 1.1. Okay, so some
Yeah.
fundamental quantities like length, mass, time, temperature, electric current, then luminous intensity.
Luminous intensity, amount of
Okay.
substance.
Now this table
Yeah.
is important for MCQ. Like, MCQ will be given like this: which of the following is not a fundamental quantity? So three options will be given from this table and one option will be given out of this table. Okay. So if you want to locate
Yes.
the non-fundamental one, then you have to know all the seven quantities up here. Okay. So the first
Yes.
thing that I will recommend you to learn is to memorize these seven quantities. Length, I will better mute everyone, okay, or else actually there will be okay. So whenever you have any doubt, you may raise your hand. There is an option to raise your hand. So you may raise your hand. I will unmute you, and then you can speak, okay, and ask your doubt. Acha. Now, what do we mean by this fundamental quantity? This fundamental quantity cannot be broken down into any one or two more quantities. Like if I ask you whether acceleration, we all know what acceleration is, right? Acceleration, whether this is fundamental quantity or not. You will say that no, sir, this is not a fundamental quantity. Why this is not a fundamental quantity? Because we see that it is velocity divided by time square. Sorry, not velocity, distance divided by time square. Or we can say that for velocity, it is equal to distance divided by time. Distance, this is a length, and time, this is time. So as you can see, this velocity can be broken down into more than one quantity, right? So this is not a fundamental quantity. But if I ask you about length, length cannot be broken down further into any more quantities, right? So that is why these are the fundamental one. If you combine one or more, if you combine two or more fundamental quantities, then you will be getting non-fundamental quantities. Okay. So this is the difference between the fundamental quantities and non-fundamental quantities. Okay. Acha. And about the dimension, we already know about dimension, right? Okay. Like the dimension of velocity, it is L T inverse 1, right? We already went through this dimension thing in SSC level, so we are not going to discuss about this in details here. Acha. So in the next class, inshallah, I will be asking you about these seven quantities, okay? Like I will ask Simon, please mention the seven fundamental quantities. So you should be telling me these seven quantities one by one, okay? You don't have to maintain the serial which is given in the book. You can say, temperature first, length at last, no problem. But you have to mention all the seven of them. Acha. Other than this, I don't think there is anything more we can study from this chapter. Oh, come to page number 25. Error in measurement. These things Actually, we will study when we study when we will do the practicals. Okay, during our practical sessions, inshallah, we will study this: the instrumental error, backlash error, parallax error. These are also important, but this one we will see in practice when we do the practical session. Okay, so we are not going to talk about that now. Uh, I guess we are ready to start our second chapter. That is vector. So everyone come to page number 48. Mainly we are going to start from here. Okay, vector. So today is your very first day of your HSC level. So we will go with the easy topics first. Okay, later on we will go up the ladder. Acha. The first topic that you have, you can see, is vector and scalar quantities, right? Now you already are familiar with vector and scalar quantities from SSC level. Just to give you a refreshing of your memory, the scalar quantities are those to express which only magnitude is enough. Like if I ask you about the length of this. If I ask you what is the length of this, you will tell me only 5 centimeter. That means you will give me a certain value only, right? Will you give me any direction that 5 centimeter from left to right or in the up direction? No direction is required, right? No question of direction appears. So that is why those quantities are called scalar quantities. Some more example of scalar quantities are time, temperature, then mass. Okay, all these are scalar quantities, because whenever I ask about I ask you about these quantities, no question of direction appears. Okay, but let us think about force. Okay, whenever you say that you are applying some force on a particular body, if I draw it on the board, let us say I drew a body on the board and I say that 5 Newton force is being applied on this body. Now the question that you will ask me is, sir, in which direction the force is being applied? Either it is in this direction, or in this direction. In which direction the force is being applied, right? Because the direction is important. Why the direction is important? Because the body will start moving in that direction in which you are applying the force, right? So in which direction the body will move now? To know this, it is important to know in which direction you are applying the force. So that is why whenever we are talking about force, knowing only 5 Newton, the magnitude, the 5 Newton, the numerical value, right? Knowing the magnitude only is not enough. We need the direction also. So this is a quantity to express it fully. We must know the magnitude and the direction. Such quantities are known as vector quantities, right? Some other examples are velocity, okay, displacement. So these things are vector quantities. Okay, you already have idea from earlier about this. So what I will request you to go through the definitions now. Okay, in your page number 49, we have the definition. So let us we'll take a look at the definition. First definition, that is a vector quantity: the quantities which require both magnitude and direction for their full description. Okay, so both magnitude and direction. If anyone is missing, then we cannot say that it has been expressed fully. Acha. So these are displacement, weight, velocity, acceleration, force, electric intensity, etc. Now all other things you have studied earlier, but electric intensity, this one I will request you to remember or keep it in your mind, especially because this is not something that you study in regular, right? Because you studied about acceleration, you studied about force, you studied about velocity, weight and displacement, everything, but not electric intensity. So this is something new. So this is what you have to keep it in your mind, because whenever examiners make questions, they try to give the options which are not actually familiar with the students, familiar to the students, right? So electric intensity, they know that this quantity you did not study well in your HSC level. So that is why knowing this, whether it is scalar quantity or vector quantity, is of utmost importance. Okay, because in MCQ this is going to come. Acha. So then let us take a look at a scalar quantity. The quantities which can be described by magnitude only, detection is not required. Those are called scalar quantities, like length, mass, speed, work, electric potential, etc. are examples of scalar quantity. So till now, if anybody have any doubt, please unmute yourself and you may ask your doubt. Or you may raise your hand. Anybody have any doubt?
No, sir.
No, sir.
No, sir.
Okay, great. So we can continue further. So you can see that the next topic that we have is properties of vectors. Okay, see, let's see what is there. Number one properties that is there is vector quantities require both magnitude and direction for their full description. We already know this. Then a vector quantity changes if magnitude or direction or both changes. This is true. Okay. Now, at first, let us say a body was having a velocity in this direction at 5 meter per second. Okay. Now, another body is having a velocity in this direction at 5 meter per second. Can you say their velocity is same?
No, sir.
Yes.
Because I think so.
Not same. Even though the magnitudes are equal, what is not same?
One is coming from
Direction.
downside, direct, yeah, from down to up.
Direction is not same.
In short, if I say
Directions.
the direction is
Direct.
not same, right? So
Yeah.
if the magnitude or direction, either one of them is not same, we will say the velocity is not same. The velocity has
Yeah.
changed. Okay. So this is there. And if it happens that another body is in this direction, but the velocity is 6 meter per second. The direction is same, but the magnitude is not same. Then also we will say that the velocity is not same. Okay. So what we understand from here, either the magnitude changes or the direction changes. Okay. দুইটার যে কোনো একটা চেঞ্জ হইলেই আমরা বলবো যে velocity চেঞ্জ হয়ে গেছে. Okay. This is the second point. Now the third point. The addition, subtraction, multiplication, etc. of a vector quantities cannot be done by simple algebraic laws. Yes, this is very true. Now, why this is true? Let us say we have a body, and on this body we are applying a force in this direction of 5 Newton, and I'm applying another force on this of 5 Newton. Now, if I ask you, what is the total amount of force that is being applied on this body? So
10 Newton.
10 Newton, that is the algebraic summation, right? The algebraic summation. At first, we are talking about algebraic summation. Now, while we are doing the algebraic summation, we do not actually consider the direction. We only take care of the magnitude. So if I add the magnitude, I can say that, okay, 10 Newton force is being applied. But if I take the vector sum, now I have to consider the direction. Okay, vector sum. Whenever we're talking about vector, the direction is important. Now, vector sum, if I take, what I have to write? I have to take any of the force or any of the direction to be positive. Let us say I have considered this direction to be positive. Now what will happen? Obviously the opposite direction will be negative now. So this force, this 5 Newton force will be plus 5, right? And this 5 Newton force is going to be minus 5 because this is being applied in the negative direction. So plus 5 minus 5, 0. So according to vector sum, the force that is being applied on this body is 0. So do you understand the importance of direction? So algebraic sum and vector sum, those are not important, and those are not similar. Why those are not similar? Because while taking the algebraic sum, we actually do not consider the direction, right? We do not consider the direction. We just care about the magnitude, the amount, okay? But while doing the vector sum, we have to take care of the direction. And according to direction, some forces, some quantities might be positive and some quantities might be negative. And the summation will be taken accordingly. So this is actually true. What is the applied force on it? Like if I pull this duster in this direction with 5 Newton and in this on the opposite direction with 5 Newton, the duster will not move in any direction, because what will happen? the force I'm applied in this direction will be nullified or balanced by the force that I'm applied in the opposite direction. So if the forces are balanced, there is no active force, right? There is no active force on the body. So as a result, the summation of forces will be 0. So in case of force, in case of vector quantities, we need to do the vector sum to get the actual scenario. Okay? So তোমাকে যদি আমি এটা বলি যে algebraic sum, this is 5 plus 5, 10 Newton. Okay? So you will think that okay, total of 10 Newton forces being applied, but this can be similar to this case also. See, in this direction I'm applying 5 Newton. Again in this direction I'm applying another one 5 Newton. So this here the algebraic sum, it is going to be still 5 plus 5 is equal to 10. But the vector sum, now this is not going to be 0 anymore. Both of them are acting in the same direction, so both of them will be positive. So now it is going to be 10 Newton for vector sum also. So you see the vector sum is not similar to algebraic sum. This is what our point number 3 is. Okay, the addition, subtraction, multiplication, etc. of vector quantities cannot be done by simple algebraic laws. Okay, so I showed you only addition and subtraction. In future, inshallah, we will take a look at the multiplication. We will get to know what is a scalar product, what is vector product, what is cross product, what is dot product. We will get to see this inshallah in future. Okay. Achha. Now, the product of two vector quantities may be 0, though none of them is 0. Here, till now what we knew, let us say in mathematics, while solving the problem, we faced this type of situation. The multiplication of these two is 0. So from here, what do we write? We write that x minus 3 is equal to 0 or x minus 2 is equal to 0. That means, according to the algebraic laws, if the product of two quantity is 0, then either one of them must be equal to 0. এই দুইটার মধ্যে যে কোনো একটাকে 0 হইতেই হবে, তখনই ওদের প্রোডাক্ট কি হবে 0 হবে। যদি এরা দুজনই নন 0 হইতো, মানে এরা দুজনে কেউই 0 না, তাইলে কখনোই এদের প্রোডাক্ট কি হবে না 0 হবে না। তোমরা একটা জিনিস খেয়াল করে দেখো, এইটার ভ্যালু আমি 0 ধরলাম, এটার ভ্যালু আমি 100 ধরলাম, তো 100 into 0 I will get it 0. আবার ধরলাম এটা 100 এবং এটা 0, again 100 into 0 is 0. বাট এখন যদি আবার ধরি যে এটা 100 আর এটা হচ্ছে যে কোনো একটা ভ্যালু মনে করো 2, তাহলে দুটোটাই হচ্ছে নন 0. So if you take the product of this two non-zero value, will you get 0? এখানে কি 0 আসবে? এখন আসবে না। তো 0 হইতে হলে দুইটার যে কোনো একটাকে 0 হইতেই হবে, তখনই প্রোডাক্ট হয়ে আলটিমেটলি রেজাল্ট আমার 0 আসবে। ওকে, so this is the case in case of algebra. Okay, but in case of vector, even though both of them are not 0, still the product can be 0, which is not possible in case of algebra. Now how it can be possible, inshallah we will see. Okay, we are just talking about the properties. In details explanation, inshallah it will come in the following classes. Okay, so now I'm just giving you the idea. Achha. So the product of two vector quantities may be 0, though none of them is 0. In case of algebra, at least one of them has to be 0. But in case of vector, even if they are not 0, still their product can be 0. Okay. The product of the 5 number point, the product of two vector may be a scalar quantity or a vector quantity, depending on the nature of their multiplication. I already told you the name of two type of multiplication that we are going to see. One is dot product, one is cross product. Dot product is also known as a scalar product, and cross product is known as vector product. So whenever we are doing some dot product, we will multiply two vector quantity. If I am doing dot product, then the result is going to be a scalar quantity. Then again, if I multiply two vector quantity and do the cross product now, then what will happen? The result that I will get will be a vector quantity. Now, hearing this, it might sound, very unfamiliar to you because you didn't actually study about this at all in your SSC level. No problem. Actually, there are in details discussion later. If you want to have a look, then I can tell you the page number. multiplication of vector, page number 67. If you come to this page, you will see multiplication of vectors can be done in two ways. Page number 67. If you come to this page, then you can see two type of multiplication of vector has been listed. Multiplication of a vector by a scalar and multiplication of a vector by a vector. So we will see, inshallah. Okay, so a scalar product or dot product, this one also we will go through. Acha. So then we have few examples of vector. So what I will request you, these are actually, theoretical things. Okay, you will study about torque here, you will study about angular momentum here. These are just little idea. Later, there is a huge explanation, okay, huge article regarding this torque. Okay, so that is why I will request you, if you want, you can go through these lines, okay, at home, no problem, but we will have the in details discussion in some later classes. Okay, so the next topic that we will study is in the next page, that is representation of vector. Now representation of vector is something we already know, right? Vector is represented by a line segment, a directed line segment, right? There is a direction indicating from which direction to from which point to which point. Do you remember this? If we have, let us say O point, and then we have P point. So the OP vector has been represented by this directed line segment. Okay, so kindly go through page number 50 also. Okay, we will start talking about a few definitions relating to vectors, that is free vector, localized vector, like vector, unlike vector, equal vector. All these things, inshallah, we will discuss in the next class, as this is just the beginning class of your HSC level. So I will just request you to read the first two pages, that is 49 and 50, these two pages today, and we will talk about the next topics in from that is from page number 51 in the next class, inshallah. Okay, so we will end our class here. Okay, as this is the first class, we are trying to keep it easy and simple. Okay.
Okay.